Unpaired electrons are there? 3 unpaired electrons. So it's going to form bonds so that it can get 3 more. It's either going to gain 3 electrons. 1 here, 1 here, 1 here. It's either going to gain 3 electrons or it's going to share 3 more electrons. Okay, so this is what they're talking about, unpaired electrons. So this is reactive because its octet isn't complete. Okay, it's got an incomplete octet. So this one's going to gain because the number to gain is less than the number to lose, right? So what element is this? Nitrogen. So if it forms an ionic bond, it will be N3-, or perhaps it could share in a covalent compound. It could share 3 electrons and make like a covalent molecule of some sort. I'm just giving ammonia as an example. Okay, so it can either gain or share. So these are the paired and unpaired electrons. Definitely want to either have 8 or none. Who's most likely to want to have none in their valence shell? To have none in your valence shell, you must have lost because everybody's got electrons in your valence shell. So who's most likely to lose electrons? The metals, yeah. So your metals are going to lose. They're going to have less than 4 normally, 4 or less normally, valence electrons to lose. The nonmetals are going to gain. And part of that has to do with our periodic trends, gaining or losing, depending on the size, right? How tightly held those electrons are, how close they are to the nucleus. Okay. We'd run out of paper. So we're going to simplify life, and we're going to start doing Lewis dot structures. And Lewis dot structures, or Lewis structures, show the element and the valence electrons. Okay? Show the element and the valence electrons. So what we do is it's just like the Bohr diagram. You put one on the top, one on the side, one on the bottom, one of the other side, and then we start doubling up. That's the Lewis dot structure, or the Lewis structure for nitrogen atom. Okay? Has a special name. This is called a lone pair of electrons. Usually these are non-bonding pairs of electrons. Electrons want to be in twos, always. They want to be in twos. They want to have a partner. So we have 3 bonding unpaired electrons. So these are unpaired electrons. And we have 1 lone pair of electrons. The most bonds nitrogen can make is 3. We'll make 3 bonds at the most, because it only needs 3 electrons. Positive plus a negative. The total positive equals the total negatives, so the whole charge is 0. Sodium chloride does not have a charge. Lithium fluoride does not have a charge. How do you know just by looking at the symbols there that they don't have a charge?
There's no subscripts.
If they're up, they're superscripts. There's no superscripts here. There's no plus or negative. Chloride is an ion. It's got a superscript -1. Sometimes we just write the negative. The 1 is understood. Calcium is an ion if it's lost 2 electrons, superscript 2 plus. So these have charges. So these have charges. We know because it says so right there. These have 0 charge. Their plus and their minus cancels out. In space, we're going to show the formation of a compound, and then I'll explain how that is different than just writing the Lewis structure for the compound. Okay, so third energy level for both of them. There's the sodium atom. So these are Bohr diagrams rather than Bohr-Rutherford, just for bonding. All we need to see is electrons. Bonding only involves electrons. It doesn't involve your protons or your neutrons. They're just in the nucleus, okay? Bonding is all about electrons. Okay, so show how sodium chloride forms from sodium and chlorine atoms. So this is what you would do. You would draw the Bohr diagram. You would show this is losing an electron. Chlorine is going to pick it up. I am showing where that valence electron is coming from, where it is going, and then the result. So you end up with sodium with a +1 charge, and you have chlorine with a -1 charge because it gained that negative electron. Yeah. Oh, you can just write the plus if it's 1. We tend not to write 1s in chemistry. Okay. So this is -1 because it gained an electron. So this is my Bohr diagram to show how sodium chloride forms. If I just draw this, I am drawing the Bohr diagram for sodium chloride. So the whole line is for the formation of, just the product is the Bohr diagram for the compound. With 1 dot. How many valence electrons for chlorine? 1, 2, 3, 4, 5, 6, 7. So again, we're going to show how it forms and then the Lewis dot structure for the product. So again, sodium's going to go over here. Our Lewis structure for sodium chloride. Sodium has no dots because it doesn't have any valence electrons anymore. Chlorine has got 8 because it picked it up. So the whole thing is using Lewis dot structures to show the formation of sodium chloride. The product is the Lewis structure for sodium chloride. So if I say to you, draw the Lewis structure for, you just have to do the product. If I say, show using Lewis structures, you're going to draw the whole line. Okay? I show how this forms, so we can do this. But the problem here, calcium still has an electron. So what do I need? A second fluorine. So you can do this two ways. You can just draw another fluorine or put a 2 in front of it. So you need 2 fluorines. So now calcium has no electrons, 2 plus. Fluorine has all 8. And there happens to be still 1 minus because they only gained 1, but there's 2 of them. You can do it like that, or you can draw 2 fluorines. You could do it like side by side. You can do that. So there's a couple of different ways to write it, but normally we do it like this. So there's your product. There's the Lewis structure for your product, calcium fluoride.